Hello, judges. Hope you are in the best of your health. Our team X8bit is working on the problem statement titled AI powered monitoring of crop health, soil condition, and pest risks using multispectral, hyperspectral imaging and sensor data. The problem statement ID is 25099. Before proposing the solution, let's understand why this problem statement matters in the first place. So, farmers today face major challenges like soil degradation, unpredictable weather, and pest outbreaks, leading to yield loss and financial stress. Traditional monitoring methods are often manual, delayed, and they're imprecise. They leave farmers reactive instead of proactive. The proposed solution is an AI powered platform that integrates remote sensing and IoT sensor data to deliver real time, field level insights into crop and soil health, enabling early detection of stress and diseases. The key asset that helps us in tackling this problem is the multispectral or the hyperspectral image of the farmland. These images capture many narrow wavelength bands beyond normal RGB, revealing details about chlorophyll, moisture, and nutrient levels. This lets us detect crop stress or disease before it's visible to the naked eye. But these images in itself aren't enough for a detailed and precise solution. We need to add environmental context, for which we use sensor data, measuring soil moisture, temperature, humidity, and leaf wetness. When combined with image data, it improves the accuracy of predictions and help identify conditions that favor pests or crop decline. It is this sensor data that allows us to give a more detailed future prediction health map instead of a normal NDVI heat map. Sensor data also helps to eliminate the anomaly in the results. We use MATLAB's hyperspectral imaging library, image processing toolbox, and deep learning toolbox. Our pipeline aligns and processes image and sensor data, extracts vegetation and soil indices, and uses CNN for spatial analysis and LSTM for temporal trend prediction. Results are visualized on an interactive dashboard with health maps, alerts, and trend graphs. Our solution is technically and operationally feasible. It integrates with Google Earth Engine, humorous dataset for continuous access to high quality imagery and soil data. Built on a scalable cloud architecture using MATLAB and AWS, it ensures fast processing and easy deployment. A continuous learning loops lets the model retrain with new crop data, and the system has been validated in major districts of UP and Punjab, confirming real world applicability. Our platform helps farmers detect problems early, optimize resource use, and prevent yield loss. It transforms farming from reactive to data driven, promoting precision agriculture and sustainable growth. Agronomists can use the spectral health maps and soil indices to diagnose nutrient deficiencies, analyze disease spread, and plan precision interventions. Researchers can access historical and real time data for modeling crop behavior under changing environmental conditions. Field technicians benefit from automated alerts and mobile dashboards, helping them quickly identify and report problem zones during field visits. These are the links to our sources that we use for research and data collection purposes. Now, I would like to give a quick demo of our working prototype. This is the dashboard of our working prototype. I'm currently in the guest mode, so I'll create my first farm. I'll name my farm my first farm, and I'd like to grow wheat. I'll select the planting date to 15th October, and it predicts the harvest date, but I like to change it to 15th of February to give it at least 4 months. This is my first wheat farm. And after that, we are enabling the users to select a 10 km square of area. So I'll choose my hometown for selecting the area, which is Agra. And I have choose a 10 km square of area right here. And I'll create the farm. So my farm is created successfully. And during the training of our CNN model, we got to find out that Agra, in comparison to the other districts in Uttar Pradesh and Punjab, it's not well suited for wheat cultivation. So I'm expecting it to give stress zone majority output. Let's see. So this is my farm that I created, and behind the scene, the front end is now calling the back end, and it's sending these four coordinates to the back end. The back end is interacting with the Google Earth Engine API and receiving multispectral image for this area, and weather API and humorous data set to get the sensor data for this area. And after receiving the data, it's converting that data into a NumPy array and sending it to a CNN model for segmentation. After the segmentation, the CNN model returns this health map for the area as an output. So as we can see here, that a lot of area here is stressed, some of the area is moderate, and even less majority of the area is completely healthy for wheat cultivation. The yield prediction at the time of 15 February is predicted to be 4.07 tons. Previously, it was 4.03 tons. And this is the separated health maps. So this is the same health map, but we have separated the colors to understand the field patterns better. And we are receiving the soil recommendations that the soil is alkaline, we have to use gypsum or organic manure, and the salinity is high, so we need to improve the drainage and apply some gypsum. So this was all for the working prototype till now. I hope you liked it. This needs a lot of refinement and professional features added on. We hope that we'll get selected and we'll convert it into a refined and an end-to-end product which will benefit the community as a whole. Thank you.